Okay, in looking at number 20, we are asked to decide who is correct. Is it Joseph or is it Susanna? So this is what we're doing. We are multiplying. So the first thing I'm going to do is I'm just going to multiply the coefficients. 2 times 3 is 6, and 6 times 4 is 24. Also, I see 3i, so I'm going to write them in expanded form. I know that I times I is the same as I squared, and I know that I squared is equal to negative 1. So this is 24 times negative 1, and there's an additional I. This becomes negative 24i. And so now I look up above, and I can see that I believe that Susanna was correct, and I showed my work to verify it. A lot of students in the previous class simply wrote down a name, whether it's Joseph or Susanna, but they had no work to show to justify their answer. I would like us to also look at number 21. When we look at graphs and we think of quadratic formulas, we should picture a parabola. I am drawing 3 Cartesian planes. Cartesian planes is what you're used to working with. Cartesian planes have an XY axis, and we are able to graph in this real plane, okay? And so if I tell you that we have a quadratic formula, so we know it's making a U shape, and it contains 2 real solutions, it may look something like this. It may be a parabola that is opening upwards, but it has to cross the x-axis in 2 places. Or maybe it's a parabola that opens downwards, but once again, it has to cross the x-axis in 2 places. It has 2 solutions, and they're both real. We are able to identify real solutions by where our graph crosses the x-axis. Now, what if I told you that it had 1 solution? It was a duplicate. It means it was repeated twice. So here we have a parabola that has 1 solution, and it's actually a duplicate. It's repeated twice. Here we have a parabola with 1 solution, and again, it's repeated twice. Now, if we're provided with a quadratic function, or we're going to say quadratic function because the equations can be parabolas that open up to the left and to the right. But so if we're provided with a quadratic function and it has 2 solutions, but they are complex, there is no reals, then it's going to either be a parabola that opens up that never crosses the x-axis, or it's a parabola that opens down, again, that never crosses the x-axis. We are going to jump up right now to 12 through 19. And I'm first going to focus on 18, 19, 12, and 13. And actually, for this purpose of today's quiz, we're going to cross out 19. I'm going to replace it today with another expression. Now, it's going to be helpful for you to know the perfect squares that you probably learned in 7th or 8th grade. So I'm just going to write down a few of them. I may not go the whole way. It doesn't stop at 49. It goes 64, 81, 100, and so on. So when I look at this, we've learned we cannot take the square root of a negative value. So that negative sign is going to jump up front. And now I ask myself, do I know the square root of 121? I do. It is 11. So although this is not wrong, mathematically we prefer to write that integer value in front of the I. But I would absolutely accept I 11. What I would not accept, that is a common mistake, is when students put plus or minus 11i. Remember that plus or minus comes when we have something like this. X squared equals negative 121. And that's when we get the 2 answers. We don't have that. We're just evaluating the absolute value of negative 121. Let's look at number 13. Again, we cannot take the square root of a negative, so that negative pops out front. And now I need to see, can I reduce this? And I know you learned how to do this 9th grade. You may not have mastered the skill. So I'm going to find 32. 32 is right here. And then I'm going to ask myself, can I take 32 and divide it by 25 and get a nice pretty answer? Nope, it's decimal. 32 divided by 16, though, is pretty. It gives me an answer of 2. This is not done. In fact, this is not done, and that's on today's checkpoint quiz. I had about 6 or 7 students that did not get perfects on the quiz because they stopped right here. When you see these 4 items, which 2 numbers are like terms that I can still multiply? The 3 and the 4. So I'm going to write down 12i squared sub 2. Let's go ahead and look at number 18. Number 18 is going to be kind of a mirror image of number 12. Again, the negative sign comes out front, and then I had the square root of 225, which is 15. And so, although I 15 is not wrong, a proper way is 15i. I would not count I 15 wrong. This is the one I want you to write down that does mimic today's quiz. So somewhere on your paper, please write down -4 times the square root of -20. I cannot multiply through here, so I can't say, oh, the square root of 80 or positive square root of 80. Can't do that. What I'm going to do is I'm going to think of these as two separate expressions that I'm multiplying. So inside of here, I'm going to take that negative sign, and it's going to pop out front, just like we completed number 12 and we completed number 18. Same thing. Now the square root of 20. 20 lands between 16 and 25. 20 divided by 16 does not produce a nice integer. 20 divided by 9, nope. 20 divided by 4 does. So this breaks into square root of 4, the square root of 5, and -4. And I know this looks backwards, but I'm going to have some open space here. When I look at these, I know the square root of 4 is 2. I cannot leave it like this. I still need to look at these three values and ask, of these three values, which ones can I multiply? The -4 and the 2. So this is -8i square roots of 5. Let's do a little practice. Let's come down below. I'd like to find where it says wanna. Please find where it says wanna. I want you to use the box method. I'm telling you that her answer was wrong. And I want you to use the box method to multiply right now. Make sure your cell phone is not out. This 4 subtract 7i can line up on top or going down the sides. Four times 4 is positive 16. 4 times -7 is -28i. 4 times 7 is positive 28i. 7 times 7 is -49. This is where it gets confusing for students. Plus we have an I squared here we need to attach. Remember, we've learned in the last few days that I squared is the same as -1. So this is -49 times -1, which equates to a positive 49. When I line up my answers, I need to put the real portion first and the imaginary portion second in the complex number. So 16 plus 49 is 55. That's the real portion. These are added to inverses, plus 0i. Let's test your abilities with i's. Let me take out a blank piece of paper. Let's see how well you remember i's. Let's start with I to the 13. I to the 13, no calculator involved. How can we do this? Remember that I squared is equal to -1. That's what you need to remember. Okay, when I'm provided with an exponent on the I that's not even, I'm going to rewrite it as 1 less. So I know I to the 13th is the same as I to the 12th times I to the 1st. And for now, let's just temporarily forget about I to the 1st. I'm going to take the 12, divide it by 2, and I get 6. If you recall, we talked about this the last few days. If you have an even number of negatives, what is your final answer going to be? Positive. If you have an odd number of negatives, what is your final answer going to be? Negative. So 12 divided by 2 is 6. So I would have 6, and you're like, Miss Bradley, that makes no sense to me. Well, if I lined up 12 of these, if you're a visual learner, if I lined up 12 of these, remember that i's go in pairs of 2 always, 2, 4, 6, 8, 10, 12. I lined up 12 of these, and each one of these produces a -1. Maybe this makes a little more sense to you now. 1, 2, 3, 4, 5, and 6. That's why you end up with 6. So I have 6 negatives. 6 negatives is even, which means I get a positive answer. So this is going to produce a positive answer, but remember, we have that leftover I. Okay, you ready? I'd like you to try the next one on your own. Please try I to the 25. Go ahead, I to the 25. I'm going to rewrite I to the 25 as I to the 24 times I to the 1st. And again, if you were a visual learner, you'd set up all these i's. So there's 2, 4, 6, 8, 10, 12, 14, right? And there would be 12 groups. There would be 12 pairs of i's. each one of those pairs produces a -1. So I have an even number of negatives. An even number of negatives produces a positive answer. This is +1, and we have a leftover I. Okay, next up, please do this one. What is I? Please listen. What is I to the 18th? What is I to the 18th? Well, I to the 18th is already an even number, so I don't need to take one away from it. So I take the even number, I divide it by 2, and I get 9. So there would be 9 groups of 2, 9 groups of 2 i's to come up with 18 i's. And since I know that I have an odd number of negatives, an odd number of negatives produces a negative answer. So this is -1. You may be saying like, well, where's the I? Don't have to put an I behind. There's not an additional I. Remember how we had an extra I to make it even? We had an extra I. There's not an extra I. This is simply a -1. Okay, here's the next one. If I can zoom in here to a free space. This seems pretty easy, but this is a really commonly missed problem. 5i times 2 minus 4i. I'm going to distribute the 5i, simplify things, and then write it in proper form where the real portion is first and the complex portion is second. 10i minus 20i. But notice there's 2 i's here, so it's I squared. I know I squared is the same as -1. So in the back portion here, I end up with -20 times -1, which is +20. All of this is great, but it's not in proper form. The real portion without the I goes first, and the imaginary portion goes second.